Start. Good evening, everybody. So it's a pleasure to welcome everybody to the next instalment of our Addenbrooke's Consultant Forum. It's a particular pleasure tonight to be joined by a speaker who's one of our non-executive directors at CUH, Professor Sharon Peacock, who is also a professor at the University of Cambridge. I'm sure that the topic of what Sharon is going to speak about this evening is going to be of interest to all of us. And just in terms of a couple of bits and pieces of housekeeping, if that's okay. Sharon does have a slightly iffy internet connection. So if she suddenly stops, please don't disappear. It will all kick up again in another minute or two. She may just need to go to another room to fix that. So do hang on there. There aren't going to be any slides. We're going to do a sort of Q&A initially between us, and then I'll ask you to later put some questions into the chat, and maybe we'll make it interactive in the second part of the session, if that's okay with everybody. And the session will also be recorded, so we can get other people to see it who aren't able to make it this evening. So without further ado, final thing I wanted to say. Sharon will also tell you about her roles, some of which are political. So I'd be very grateful if people don't try and push Sharon this evening to make political statements or comments which she won't make, and we should make sure that we respect that for her, please. So I'm very grateful to you all for that. Okay, so if we make a start, Sharon, could I, it's okay with you, thank you for joining us. We really appreciate it, and we really appreciate how busy you are. Can you just give us a bit of a background introduction to what you do and the multiple hats that you wear, please, and then we can sort of have a chat about some of those roles.
Certainly. So it's an absolute pleasure to be here. Thank you to everybody who's turned up to listen to me. So by background, I'm a clinical microbiologist, actually, and I'm an honorary clinical microbiologist at Addenbrooke's Hospital. In the past, I've run diagnostic labs at, for example, the John Radcliffe Hospital in Oxford. And so I'm a sort of trained microbiologist and virologist. I am also the director of the COVID-19 Genomics UK Consortium. That's the consortium that's doing all the sequencing at the moment. And I can tell you a little bit more about that in a minute, but certainly I am responsible for generating all the genomes in the country, and we've just hit the 200,000 mark. I do have quite a few political roles. So I'm a director of science in PHE. I sit on SAGE. I also set up several SAGE subgroups. So I set up the hospital onset COVID-19 working group, and several other, I sit on several other working groups. I do have quite a lot of sort of input into that. And finally, as Justin has already said, I'm a non-exec director. So I actually joined the hospital as a NED in 2015, in September 2015, just as the hospital had gone into special measures. And my area of expertise is really quality and safety. So I chair the quality and safety committee, as well as sit on the board. So many of you might have seen me on quality and safety, and so and that's a role that I value very much, actually.
Well, thank you. That's a great insight. So you mentioned there the COVID-19 Genomics UK group. Could you just tell us a bit about that, sort of what it is, how it got set up, what it does? That would be interesting, I think.
Yeah, sure. So this is really interesting. I think that as a country, we've been very strong in pathogen genomics for a decade, and there's lots of people who are really kind of passionate about the importance of pathogen genomics in public health. You sequence a pathogen and then you use that information for public health good. And it was actually on the 4th of March, and actually there were only about 84 cases in the country, that I picked up the phone to 5 of my genetics colleagues to say, do you know what, I think we're really going to need to have to sequence the virus. I don't know what direction it's going in, but this is not looking so good. What do you think about setting up a consortium that's able to sequence the virus in close to real time? And there's quite a bit of enthusiasm. So by the 11th of March, we were meeting, there were 20 people around a table trying to work out a blueprint for how we would do this, because there wasn't any provision for that at that point. So we met and we developed a blueprint, and then wrote up a proposal by the 15th of March. And by the 18th of March, we convinced the government to give us £20 million of funding to set this up. So it was a frenetic time. And looking back, it was probably rather bold and risky, because we were asking to do something, the value of which hadn't been demonstrated. And we did have our detractors saying, well, what do you want to do that for? And it's really only now that we're seeing these mutations arise, and actually the future is looking like more will come, and I can speak about that later, that actually way back in March, we thought, actually, do you know what, we need to set this up now. And right now we have all the methods ready and the analysis tools and the environment to put the genomes, and we are way ahead of actually other people. So we have sequenced half of the world's viral genomes to date. So that's the story of actually how it got set up. There was the political will to fund it, and you might think £20 million sounds like a lot of money, but we've actually sequenced 200,000 genomes, and actually a lot of that was done through volunteer. So very little of that money went on staff. It mainly went on sequencing the organism.
Amazing how quickly it's progressed. In terms of the mutations, I mean, obviously we've got a mix of people on the call, but can you just sort of tell us what it is about them that makes them important, and why you're sort of particularly interested in them, please?
Yeah. Well, the virus has got about 30,000 sort of genetic letters in its genome. It's an RNA virus. It's got about 30,000 letters, and I mean, pathogens mutate all the time through evolution, and the virus itself mutates around once or twice a month. So during replication, it makes a mistake, and the wrong base gets put in, and so it kind of makes a mistake in its genome. Now, why is that important? Well, over time, the virus varies more and more and more. Most of those mutations don't matter at all because they don't have any effect. But if that mistake leads to a change in the amino acid that base is coding for, that can lead to a change in the structure and the function of the virus. Now, that's important because it can change the way the virus behaves. So I worry about 4 things really on that list. It's quite a short list, but it's quite important. First of all, it could change transmissibility, and we can come on to talk about the new variant in a minute. It can change lethality. So does it kill more people? We can also discuss that. Does it change immunology? Is it finding a chink in the armor of immunology, so you get reinfection or vaccine failure? And finally, does it really muck up how your diagnostic tests work? So, you know, mutations are so important to the way that this pandemic is now going to pan out between now and whatever the future may hold. That's what we're tracking. We're looking for mutations where we get worried about where they are in the genome because of what they might change in the virus, and what implication that has for the patients that you all treat.
Thank you. So, in terms of the transmissibility, you know, have you learned much about how the mutations affect that, and has that sort of led to any changes in practice or of how things have been managed at a national level?
Yeah, I mein, we had a bit of a practice run at this in April. So when the virus first evolved and emerged, it didn't have this particular mutation in what we call the spike protein, which is the thing that kind of interacts with the human cells. And it's got a name. It's D614G. That just says where it is and what replacement, amino acid replacement it had. And in fact, that was a bit of a practice run because that changed transmission. We didn't make much of it. You won't have heard about it. It wasn't kind of a big thing. But basically, that's in all the viruses that are circulating now. It's gone to fixation. But what we're really worried about is the new variant that has been detected first in the UK, in the south of England. And, you know, that appears to be about 50% more transmissible than the circulating variants. And that means that it's going to spread between people more. So going back to when that first emerged, we noticed that in Kent and London, there was a surge in cases, even though people were in lockdown. In other places, that lockdown was kind of working. And it was really when the genome was brought together with the surge in cases that the kind of the light bulb moment that actually the two were associated and there could be a cause and effect. So I think that it was too late actually to stop the new variant spreading across the country. It spread like wildfire actually. I think that it's led to countries closing their borders and to stop the new variant coming in. I think it's actually almost inevitable that the new variant will spread across the world, and because many places are not sequencing, it's likely to have done that already. But actually, if we can get, if the thing that really worries me actually is something that's very spreadable, but actually has a feature that means the vaccine doesn't work as well. So I think that we need to get really smart at spotting those as they emerge and take particular care to try and contain them. We're learning all the time, but we need to kind of jump on those because they would be extremely concerning.
Absolutely. And we perhaps, obviously, we'll talk about the vaccine in a minute or two. I mean, has any of the work that you or others have done shown us why this new variant is more transmissible, what it is about it that makes it so worrying, as you've just said?
Well, actually, it's a bit of a conundrum. It could be more transmissible because the virus latches onto the receptor that it needs to get into the body with more effectiveness, or it could be that you excrete more virus and so you're more kind of infectious. But the first clue about what was going on was that people reported that the CT value, that's kind of the value you get on your PCR assay, which gives you a kind of rough approximation of how much virus you got in the sample, suggested that there was more virus in samples from people with the new variant than people without.
Ooh, there's that Wi-Fi hotspot.
Patients, and you look.
Sharon, we lost you for a split second there, Sharon.
Oh no! Can you hear me now?
We can. We only missed about 10 seconds, but I thought you were going to be heading to the garden. But
oh my goodness!
You're back.
Yeah,
you're back.
It's very stressful doing this when you know that your internet's terrible. So, so what we know is that when you look at the amount of virus in on each day from a person with a new variant versus a kind of a previous variant, there doesn't really seem to be a big difference in the actual viral burden. So we're scratching our heads at the moment, actually, as to why it is more transmissible. We know it is. We know it must have something to do with the way it interacts with people. But I was quite surprised. I only heard today that if you sample people every day over time, that it doesn't seem to be a higher viral load. That was a small number. It's about kind of 18 patients so far. So we have to take that with a bit of a pinch of salt.
Okay.
So it's work in progress, quite honestly.
Thank you. Just a note to everybody who's listening in. If you have some questions, please feel free to put them into the chat as well, and we can work through those later on. So I'd be grateful if you just did that as we went along. So we were talking about variants, and there's also more than the UK. So those, a simple surgeon, I don't know anything about it, but you hear the news and people talk about South African variant, the Brazilian variant. How does all of that fit in with what's going on? How worrying is all of that? And what do we know about these other variants and how they sort of fit in with the UK situation?
Yeah, well, you're right. There was a variant that was first identified in South Africa and a variant first identified in Brazil. And the reason that people are getting very excited about this and concerned is that those variants have got the mutation that our variant has, which is associated with transmissibility. It's called 501Y. So we know that these isolates are more transmissible than the old variety, but they've also got one or two mutations that could change the immune response. And there's one particular one, it's called 484K, where we know that in laboratory experiments, the amount of neutralization of the virus that takes place is reduced. And that means when you've got a virus and it's got that mutation and you bring along antibodies that have been raised by somebody who's had infection, which should kind of neutralize it, kind of, basically neutralize its effect, the amount of neutralization goes down. Now, what we don't know is how that translates into clinical effect. So it's not possible to say, we see this, therefore the vaccine has X reduced efficacy. And at the moment, there is no evidence that vaccine has reduced efficacy. But I think it's a proof of principle that the virus is beginning to ratchet up how it's structured and functioned, so that it could try and find chinks in the armor of our immune system. And in particular in South Africa and Brazil, people are concerned that individuals who got infected in the first wave are getting reinfected in the second wave. And there's a lot of work going on to say, is that due to this this variant that they have or not? So I think that the jury's out on that. But the concern is that we will end up playing cat and mouse with this virus as it mutates and it changes its structure and function through mutations. And the really interesting thing is that what we're seeing is these mutations are arising all around the world in different lineages. So exactly the same things cropping up all around the world, which must mean it gives the virus a selective advantage, a fitness advantage that allows it to outcompete with other viruses. So that's the story with that. At the moment, there's no evidence that these variants are going to not be, that the vaccine is not going to be effective. But I think it foretells of a future where we're looking at the mutations, we're looking at the vaccines, and we're saying, do we have to tweak the vaccines? I think that's what we're looking towards.
On that front, there's a question that kind of relates to that in terms of if we end up with a variant that escapes current vaccines, will the work that's been done over the last year allow us to develop a new vaccine more rapidly, or are we literally back to square one, do you think?
Yeah. I'd say two things. One is it's unlikely that any one mutation completely wipes out the effect of a vaccine. So I think that's the good news. I think it's going to be kind of a ratchet of more and more mutations. But the second thing is absolutely. So, for example, the Oxford group are already looking at these mutations to see how they could tweak the vaccine. And the mRNA vaccines can be tweaked very quickly. So the time limitation will not be in developing a new construct for the vaccine, but actually getting the vaccine manufactured and out. That's going to be the time constraint. So we're going to do it much quicker. We've got the blueprint for the vaccines. They're going to be fast, but it's going to be the manufacture and the rollout. But I think that this is crystal ball gazing, because perhaps we never get there. But I think that people are worried enough to be saying, the manufacturers are saying, okay, let's start to look at these variants that we're seeing to see how would we make a new vaccine. And quite honestly, we were never going to have one shot and that was going to be it. Immunity to coronavirus is waning quite quickly. So we were always going to be in a circumstance where we were going to have boosts and further vaccination, perhaps every year or every 2 years. What we're looking at here now is a much more complex picture, because it won't be like influenza where we go, well, what's the most likely vaccination? And we give that to everybody. We're going to have to be playing, as I say, cat and mouse with this virus as it evolves and trying to understand. And I mean, this is a stretch of the imagination, but perhaps it's, we might have to personalize it for different countries. So different countries might have the same repertoire of mutations, but they may also have unique ones. So we're going to have to, and that's why sequencing is so fundamental, because if we don't sequence, and many countries are not sequencing at the moment, they haven't got any idea what's circulating in their country unless it gets imported to a country that is doing the sequencing.
Thank you. So you mentioned about the impact of the mutations on viral transmission. Do we yet have any data in terms of the different mutations and their clinical impact and severity of the clinical condition that ensues in terms of the different mutations?
The mutations that we've looked at to date, including the D614G, the one I mentioned earlier, there was no evidence of lethality, increased lethality. I think that at the moment, there is no evidence on these new variants, but that's a lack of evidence at the moment and not evidence for no effect. I think it's important to make the distinction. So I'm not saying we've definitely proven there's no effect on lethality and we can be confident about that. What I'm saying is that this work is ongoing, and at the moment the evidence isn't there that it has an impact on lethality. But actually, this could happen, and I think if we see it, it's going to be a small difference. So we might see a small increase, we might actually see a decrease. But the point of sequencing people who come into hospital is to say, if you sequence the new variant and you sequence the existing variants, and then you look at people to say what proportion need oxygen, ventilation, what proportion die, you're then going to have an odds ratio for, you know, the increased lethality of the new variant. And that's exactly what we're doing at the moment. So I think what I would say is watch this space, because we're not certain about the 117 variant that we've got in the country at the moment.
Are there ongoing mechanisms in place in the UK for surveillance of these mutations, trying to pick up new ones as quickly as we can? And then again, what about other countries? Are there any other countries as geared up or more geared up than us in that regard?
We spend our whole days doing worrying about surveillance, and Public Health England and also Wales, Scotland and Northern Ireland, they're putting in place mechanisms that are going to detect signals that will be worrying, i.e. what's your death rate overall versus the number of cases that you've got. They're also putting in place mechanisms to look at mutations in people who are immunocompromised versus people who are not. So viruses, people who are immunocompromised, because they often can't get rid of their virus, that's almost like a kind of, the hypothesis is that more mutations arise in those viruses than in people who manage to eradicate the virus. So there's a whole host of surveillance mechanisms in the country to say, is there a surge in cases? Is there a signal of increased lethality? And we also putting in place surveillance mechanisms for reinfection and vaccine failure. So when you go and get a test, what's going to happen in the near future is you're going to be asked, have you had infection before? Have you had a vaccine? Because we want to sequence those viruses. They may have found a chink in the armor of our immune response. So you asked Justin about other countries. Actually, we are, I would have to say, the best placed country in the world, because we have got the system set up. And other countries which have done extremely well actually in their response are only now beginning to realize that sequencing would be a jolly important thing to have. And so I think that each country has its sort of strengths and weaknesses in the way that it's responded. But sequencing is up there for the UK as something that we have done. We had the sort of foresight to put in place so that we have it when we need it, and we are going to need it. But we're spending a lot of time on calls with other people, especially, including in Europe, and they're saying, how did you do it? And how can we do it? So I think that it does mean we'll find many variants. So we could be stigmatized. We could be the country that's labeled with having all the variants. But I think we're doing a service to the globe because we're detecting them, and we shouldn't be penalized for that.
And this, I guess, might be an obvious answer, I hope not, but in terms of that inequality of work going on, we're clearly ahead of the game from what you've said. What are the implications of that on a global pandemic sort of scale, do you think? Does it just mean that things are going to take longer to be controllable? Does it mean that people aren't going to be flying around here, there and everywhere for longer, or do we just not know what it means on a global scale?
I think that, so we're generating about half the global genomes at the moment. And I think that the fact that many countries are not doing it at the moment means that we're completely blind to whether people have got serious variants that are, evading immunity or are more transmissible. So I think that what that means is that you only start to see those variants when there's an important clinical signal, like there's a lot of spread, there's a lot of reinfection, or when they start to actually go into a country where they're doing sequencing. And I think that what that means is it gives the virus an opportunity to spread before public health officials are alerted to the fact that there's a problem, and therefore the control measures that you're doing are the control measures you're doing. You're not going to necessarily kind of up the ante. But what I would predict is that as we see more mutations such as this, it may well change people's attitude towards border controls. And we know that the government are thinking about different changes in quarantine, really on the back of these variants that are arising, not necessarily the one in the UK, but the ones from elsewhere. So I think that we can start to see, I think, how kind of there's going to be a global shift once again about how people, how travel corridors are permitted. And there are now discussions about global initiatives to set up sequencing, but I think that many countries are kind of, that they're going to be managing the pandemic without this information. And I think that I'm just fortunate, I think we're fortunate that we do have that information to guide us.
Yeah, thank you. We were talking a bit about vaccines. We started talking about vaccines earlier. And as the vaccine sort of program rolls out, I mean, do we have any sense of whether that rollout vaccination program might actually have any impact on the emergence of new strains? Could it make new strains more likely? Will it not have any impact on that? Do we have any idea of what that impact will be?
I think that most of the mutations, well, the mutations that have arisen, they've done so without any vaccine. So we know that these mutations are simply going to occur, vaccine or no vaccine. So that's kind of my starting point. But if there's a lot of cases, and that virus is actually being exposed to people who are partially or fully immune, it's inevitable that there'll be a selection pressure on that virus to try and find a chink in the armor and try and
Where's the salad?
Apologies. If everyone could just be on mute, that's great. Thank you.
Salad's in the fridge probably. So I think that, you know, we've got to roll the vaccine out. It's the only way we're going to get out of this situation. So there's no other way around it. We've got to get it out. And I support the view that we get the first dose out to as many people as possible to give them, you know, at least 90% protection. But your question is a really good one, and that is, are we going to kind of have a dance where we have a partially immune population and quite a few cases where the virus gets an opportunity to become selected for, to get round our immune response? I think that overall, there may be that you've got a point there that mutations may arise more rapidly that get around our immune response as we have a partially protected population. I can't be sure, to tell you the truth. I've been wrong so many times during this pandemic, you know, and I have to admit that. And I never assume anything. So I think we have to wait and see. Okay. And I think it's the right thing just to get the vaccine rolled out to as many people as possible, but then have this sequencing capability to watch out for what emerges.
I'm going to link a question that's come in there, Sharon, if I may, and I don't want this, as I said at the beginning, to be in any way a political question. It genuinely isn't meant to be. So the question is, how worried should we be about the Israeli data that indicates rising numbers of cases despite the first dose of the Pfizer vaccine, and how that fits with the current UK vaccination strategy? And I guess that's around the 3-week to 12-week scenario. Yeah.
I think the first thing to say is that I really want to know that the evidence is robust. And over the last few days, I've seen so many different papers, some saying one thing and other papers contradicting it. There's a huge lack of standardization of the way that assays are done. You know, the amount of virus you put in the assay, the controls that you use, the type of strains that you're using. And I think that, I don't think we should jump to conclusions. I think that we need to be, to have very robust information before we start to say that the vaccine in real life is not as effective in clinical trials. So I think that I'm not certain at the moment. I think that we need to be developing our own data. We certainly are developing our own data on that. I would be disappointed if it was as pessimistic as we hear. But I think that we have to be careful, because a lot of these papers are being rolled out with very small patient numbers, not peer reviewed. So they're just going into the literature. We'd never actually accept data like that normally. So I think we have to have, you know, the sense to say, is this really sufficiently robust? Is the assay standardized to an appropriate level? And it's like when the kind of so-called mink variant arose, the cluster 5, and everyone got terribly worried. Actually, that variant just disappeared, and the initial study that showed lack of neutralization in a neutralization assay, it kind of just went away. So I think we have to stand our ground. We have to develop the evidence and not be you know, too sort of scared about small studies until we really know the truth of it. Otherwise, we'll end up kind of being constantly blown about and thinking one thing and then thinking another.
Sure.
I think we have to be really careful about that.
In terms of, you mentioned the sort of mink variant there. Someone else, and I know this is slightly off the topic of mutations, which we'll come back to, but someone else has asked whether there's any conclusive evidence for animal to human transmission. And if not now, do we have any, is there any sense of how likely that is in the future?
Mm-hmm. There's been a lot written and talked about in terms of animal to human, and I think that that in our society we don't actually tend to mix with animals very much, and I certainly wouldn't be worried about if I was a cat or a dog owner. You know, I am. I don't have any concerns about that. I think that the area that I would be concerned about is when the virus passes back and forth between a human and an animal, because that's a situation where a virus can actually evolve to one species and then go back the other way. And it could be that it kind of acquires a mutation that actually makes it more adapted to the human. And I think a good example, the mink, actually, it did go from animals to humans. There's clear evidence that it went from animals to humans, and probably back again, actually. And that was why, unfortunately, all of those mink were culled. The cluster 5 was concerning because it had these mutations in the spike protein that made you think it might evade the immune response. But I think that kind of interface between animals and humans is a hotspot, and this is likely to have been where this has arisen in the first place. You know, that dynamic interaction. But for most of us, I really don't think it's of any great concern. I think that the concern would be in things like mink farms where animals can develop COVID very quickly. That can spread to humans, and that's kind of an environment where evolutionary changes can take place.
Thank you. Heading back a little bit towards the mutation side of things, is there something, do you think, super special and worrying about this particular virus and the fact that these mutations seem to be happening so quickly? Or is it just that with work that, you know, particularly you and your colleagues are doing, we are just detecting these changes so much more rapidly than we might have done with other viruses in the past? Because there's certainly this sense of, I don't want to say panic, but significant worry of how quickly these mutations are appearing. And yeah, that's my question. Is it the virus being super clever, or are we super clever in detecting it?
The virus is mutating at the rate that other coronaviruses mutate at. Oh, my internet has gone down just for a moment. Am I back?
You never went away.
Oh, good. It's just, I thought it frozen. So coronaviruses mutate at around one or two mutations every month, and that's what. If you think that mutations occur when viruses passage through people, there'd be 90 or more, and every time that virus infects somebody, it's got an opportunity to mutate, because you know viruses don't persist, but they don't replicate in the environment. They have to replicate in us because they subvert our kind of cellular machinery. So actually, the amount of mutations is in part a function of how many cases there have been on the planet. But the rate of mutation is very pedestrian, but it's when you amplify that with time and with the number of cases that we've had. So it's pretty much what we expected. The virus doesn't mutate as quickly as other viruses, including HIV and influenza. But it's problematic nonetheless because of, as I say, the number of cases that we've had, and also the extent of time over which we will be living with this virus, which is going to be for a very long time.
A very long time. Can I push you on that? What's your best? You said you've been wrong lots of times, but
yeah. Thanks for that, Justin. Yeah,
no problem. We like the easy questions.
No, yeah. I think it's going to be here forever.
Oh, I mean, Sharon, that wasn't the answer we were after.
Well, sorry, but I think in the end, you know, hopefully it's going to attenuate. So in the end, it's going to be perhaps a pest, and it doesn't really cause as much harm. But under what circumstances would this go away? We could try and eradicate it like we've done polio, but think about how hard it is being to eradicate polio. Polio vaccine is very effective, and they haven't had to keep changing their vaccination. So we will. My belief is that this virus is here to stay, like other coronaviruses. My hope is that it attenuates so that it doesn't bother us so much. And at the moment, we don't know for sure whether vaccination will prevent us from getting reinfected. Probably not, actually. We'll probably get reinfected, so we can still transmit to other people. But we won't get symptoms. So I think that it's going to be around. Perhaps it will mutate itself out of business so that it becomes quite kind of defunct in terms of how serious it causes the disease. But I'm sorry to say, I don't think we're going to get rid of this now that it's with us.
Okay. Well, if we bring the timescales of forever back to the next few months, then, in terms of the picture of the mutations that you've been describing, how do you think the sort of mutations are likely to influence the pandemic over, let's say, the course of this year, and any recommendations that you think are important in that regard?
I think that the new variant that we have, the B.1.1.7, is here to stay. So this is going to be a very prevalent strain, and it's spread across the country. It's sweeping through the population, and I think that that's what we have. It obviously has a fitness advantage versus other viruses. It's sort of out-competing them. So it's a sort of it's a kind of supercharged. I think that for the rest of the year, I think it's going to be a question of getting to grips with that in the way that we know we can, through washing our hands, face masks, distancing, etc., etc. That we can never let that go, and those mechanisms still work. So I think it's getting to grips with it. I think that this virus will spread around the world. I think it's probably inevitable that will happen unless people have got their borders closed. So I think that's that story of 117. I think what happens next is whether 117 actually develops mutations that then lead the virus to become less affected by vaccines. So the key for me is watching what happens to 117, which is already a supercharged transmitter. If that was combined with something that altered the immune response, then you start to get worried. And in fact, that's why we're worried about the variant in South Africa and Brazil, because that's exactly what they are. So I can't predict the future, and mutations are an act of nature, and they're random, although selected for by particular characteristics which allow them to persist. I think that I would say we're going to have to watch these variants like a hawk, and act accordingly. If you were to say what is it going to be like by Christmas, I think that with more mutations and variants arising, I think it's inevitable that that's going to happen. Okay.
So in terms of the vaccines that are currently being rolled out and presumably still in development, are there any particular issues with the different types of vaccines and how they work in terms of being able to tweak them according to future need, as it were?
Well, I think that the vaccines that we've got at the moment can be tweaked quite readily, so I don't have any concern about that. At the moment, they're all focused on the spike protein, and that's the part of the protein that kind of interacts with the human cell and kind of docks on and gets entry. And it's in the spike that we're seeing the variation, the mutations, and so perhaps vaccinations are going to have to diversify. But actually, the rate of vaccine development has been so staggering that I think we will see further vaccines develop quickly if we need them. And as I say, people are already beginning to work out what the next steps are.
Okay, thank you. If anyone has any other questions, please put them in the chat. Will Gelson, who's one of our hepatologists, is asking whether if influenza was seen by a population for the first time, I guess he means sort of now, do you think that the disease would behave in a similar fashion to how coronavirus is behaving?
Well, I think that it will depend on the characteristics of the particular variant, if you like, or strain, because we did have a flu pandemic back in 2009, and people were very worried about that, but it turned out to be not as transmissible or as lethal as people were worried. But I think you've only got to look at Spanish flu. So Spanish flu came into the population, swept through the population and killed a very large number of people. And the reason that they did that was because there was no immunity in the population. So we've got no immunity to SARS-CoV-2, no immunity to in the population, and it had a high attack rate and lethality rate. So it's still possible that this could happen with flu, actually, that something arises that's both novel, we don't have any immunity to it, and it has a high kind of virulence. So that's exactly right. This is like the flu in terms of sweeping through the population who are not immune. And that is really history repeating itself, to tell you the truth. It's Spanish flu all over again, except it's a different virus.
So every year we have a flu vaccine. Do you think that the SARS-CoV-2 vaccine is going to therefore need to be tweaked annually, and it becomes an annual jab, just like the others that we take? May well
be actually, and I think that we will certainly need to have repeated vaccines, because our immune system, immunity to coronavirus, if you look at other, like the common cold, which is a coronavirus, you tend to get kind of disease sweeping around every 2 years. So we have immunity, we get it, and then we get it again because our immunity wanes. And this is what happens with the coronaviruses. So we're going to have like booster doses in all probability. I mean, you have to take some of what I say, there's confidence intervals in terms of the accuracy of what I say, but I would predict that that we will end up having to revaccinate the population regularly. And as I say, we may end up having to tweak the vaccines that we're giving.
So do you have any, so from what you said, it sounds as if in the short term, and there's unlikely to be any significant let-up in terms of the virus being prevalent. But in terms of hospitals and how they are managing patients with coronavirus and very sort of separate facilities, if this is around for as long as you're suggesting, do I assume that it's likely that hospitals are going to have to be working in a different way moving forward, or over time will there be less worry about transmissibility? I'm guessing not.
Well, what I hope is that the vaccine will allow us to bring this under control so that we have much lower numbers. And I think that once we have much lower numbers, our test and trace will be more effective, because people are overwhelmed at the moment. But if we have much lower numbers, then it may well be possible to contain those cases more effectively. So my scenario is not where we have fever hospitals as we used to have, but where we actually have a vaccinated population and a smaller number of people getting infected. So I'm hoping that, come the summer and into the autumn, that when vaccines have been rolled out, that we will have turned the corner. But I think that there will be people who refuse vaccine, and that as there always is. And so that I think we'll continue to see people who have quite severe disease, but I'm hoping that the number of people that come in is going to be much reduced. And I'm really glad to see that in the country this week there is a signal that things are beginning to level off, and maybe starting to turn the corner on this particular wave.
I'm not asking you to make any predictions, Sharon, about this wave and timing of lockdown, but clearly a couple of weeks' time is going to be unrealistic. I guess there's the possibility that if we show that it gets things under control, that it may end up being significantly longer to some extent, or having to come in and out and keep, having to be reinforced, for want of a better word. Does that sound reasonable?
Yeah, I think that's what's likely to happen. I mean, we've got quite a long tail of cases that we're going to be seeing in the hospital. So I think that I mean, I participate in the modelling group in the hospital, which are superb. And what people are trying to model is how slow plateau, or whether it's going to go down very quickly. But I think there's going to be quite a long tail of cases, actually, of people. So over some weeks. But as we go forward, I think that are we going to get back into another wave? I kind of hope not, but it depends how quickly we can get the vaccine rolled out and how effective that is. So
Okay.
I think that once we start to all go to restaurants and cafes and things, is it going to bounce back? That will depend on the balance between how many people are vaccinated and how effective that vaccine is. So I think it's possible that we will end up in a kind of another bounce, but I'm just hoping that it's not as bad as this one. In fact, I'd be really surprised if it was,
Okay,
given
well,
that we've got the vaccine rolling out.
Yeah, absolutely. And sticking on vaccine and vaccine design, question coming in around a bit of sort of outside the box thinking. Is there any value in modelling vaccines around theoretically sort of troublesome mutations, and then using multiple variants of RNA in regular vaccines to try and get ahead of the virus? Can we outthink it, or is it cleverer than us?
It's just scale. People are doing that, but I think, I mean, I maintain a list of mutations that are theoretically worrisome, and I think the list is running at about 247 at the moment. And then we keep a list of mutations that we've seen in the viral population, and that's about half the size. It's about 130. So yes, you can do that. And people doing computational biology to say, well, this particular mutation is going to be problematic because it actually changes the structure and function of the virus and how it interacts with the immune system. That is happening, yes. But it's the scale of what we're facing here. And so you can do your best, but there still might be some surprises to come yet. It's early days, actually, in terms of how we understand what these mutations really do. We can even have a theoretical idea, but then trying to prove that is another matter.
Thank you. Question from one of our paediatricians around, do we understand why children seem to be sort of only mildly affected on the whole by the virus?
I'm sure that if I was an immunologist, I would know the answer to that. But I'm afraid that my knowledge ends there. So I have to hold my hands up and say, I'm not the best person to ask that.
No problem. Thank you. I've gone through most of the questions that have come through on the chat. If anyone else wants to ask anything on the chat, please do. There's sort of 125 people listening in, so I can scroll through if people want to put their hand up to ask a question directly to Sharon and see if anyone is wishing to do that. And as I'm just looking through, and I can't see any hands going up. I'm going to put Ashley on the spot, which I'm sure he'll be really grateful for, and ask Ashley if there's anything you wanted to say to Sharon, and I guess as thanks as much as anything else, but anything else you wanted to ask from a vaccination program or any other trust perspective.
No, I mean, thanks, Justin, for putting me on the spot.
You're welcome.
Always well received. I'll remember that. So I guess, Sharon, at the moment, I think that everyone's doing a fantastic job in the organisation. When you look across the whole country and you see the responses, etc., I just wonder how you see that comparing. I mean, are we doing everything that we should be doing? Is there something that you sitting there from Sage, etc., is there anything we should be planning to do that we're not doing? Anything that you have any insight that you would sort of say, I wished you were only doing this a bit more as well?
Well, Ashley, you'd be sure to get an email from me, as you do, if I thought that there was something. And the great thing is I will often email you and say, what do you think about this? No is the answer. I think it's horrendous everywhere. And what I've seen is incredible responses in the hospital, in Addenbrooke's Hospital. And I'm just in awe, actually. I'm just in awe of what's going on. So I haven't got any pearls of wisdom. I can only offer my services to you in whatever I can do in terms of my understanding of modelling and the information going on nationally. But, just a massive, massive thank you to everybody for the work that they're doing and working under such difficult circumstances, and just thinking about people taking care of themselves, particularly as we go into the future, when the kind of impact starts to hit on people's, the problem is now, but also in the future, having to deal with the memories that you have. So I've got no pearls of wisdom. I will pass them on to you. I know your phone number, Ashley, but just take the opportunity to thank everybody.
And I guess there's one other thing is, obviously I'm with David sort of, running the vaccine program at the moment, which seems to be going well. There are different approaches, which obviously I suspect have been modelled quite extensively at a national level. I know in Southeast Asia, they're, as Duncan's sort of put in the chat, they're going for people of working age to try and reduce spread. We're going for a different approach on the JCVI with single things. I was just wondering, have you had any insight into the modelling of vaccination programs and the theoretical?
I think that one of the things that have been talked about a lot is how to reduce the number of fatal cases. I mean, kind of that has to be the key driver, and then you have to work that through as to who you vaccinate in order to avoid cases in kind of people who are 60 and over. So all of the modelling's really been driven on that. And I think that what we're doing is actually quite consistent with what a lot of other countries are doing. So I feel quite kind of sort of encouraged by the approach. I think that the single vaccine and having a gap of 12 weeks is a decision that had to be made because it's better to have lots of people partially, sort of 90% immune than giving those vaccines to half the population. I think that the outcome from that will emerge over time, but I nonetheless would also stand by that because, faced with so many people who need to be vaccinated, the chance of actually trying to get cover for the elderly, more of the elderly, as quickly as possible was the right call. But as I say, I think the time will tell as to how that affects immune responses and so on.
Thanks, Sharon. Back to you, Justin.
Thanks, Ashley. Sharon, a question that is a little political, so I'm going to rephrase it a bit, has come in the saying, what would your advice be to President Biden? I guess the question is really therefore, should the US be perhaps doing something different? And is there anything that, without wishing to be too modest about it, they and the magnitude of issues they have might learn from the way we've approached things here or anywhere else in the world?
Well, I think the first thing that he will do is put together expert panels and listen to advice. We've heard this mantra about listening to scientific advice, but actually it's really important. And I'd like to see scientists actually talking about the disease in the US and not sort of politicians. So get your experts around you, get the best advice, follow that advice. And I think they've got a long way to travel in terms of quite a lot of their response was hampered. So I would put in the money, make sure that there was an appropriate structure. I know there's a new head of CDC. So I think you've got to get the people, the expertise, and the money, and drive that forward. They've got so much to do. Actually, they've got a really a long way to go. They don't have sequencing at the moment to any great extent. And they've got the experts, they've got the machines, they've got the technology, and that's going to have to be invested in too. And they'll have issues about connectivity across the country, of course, because it's so large and it's split up by its healthcare. But I think it's so important to listen to your experts and get the advisors around you that are kind of top notch. So let's hope that the US can actually start to turn the corner in the coming weeks and months.
Well, talking of experts, you've certainly been exactly that tonight. It's been absolutely fascinating. The number of people on the forum has broken our record as it stands. So congratulations. And I think it shows the huge amount of interest and also respect that we have, and thanks that we have the other way around. You were thanking us. We would say exactly the same to you.
May I ask a question?
So thank you. Oh yes, certainly. I was just going to try and get away on time there, but Jerry Clare.
Thank you,
has a
Professor
question.
Peacock. I got COVID. I had COVID in November, December, and of course it was mild COVID, but I lost my sense of smell. But then recently, everyone's been asking me, "Have you had the vaccine?" And I think I've been exposed to every protein that COVID could throw at people. So I don't think I need the vaccine. And wouldn't it make sense if the government excluded people who have been infected with COVID from vaccination? And that would free up a whole load of vaccines.
Well, you might think that, but actually the immune response wanes quite quickly after having had disease.
But presumably then it wanes quite quickly after having had vaccination.
It's likely to. But you are not protected from having a second episode. So I think that that the advice is that you do have vaccination, and in addition, if you were to actually gear your vaccine program to only those people that hadn't had the disease, you'd also have to know information on everybody who had the disease. That starts to get very complicated.
Well, I got my PCR test from the NHS, so presumably it's recorded somewhere.
And could I ask you, will you have a vaccine?
No, I don't see any point. I've been exposed to, the antigens and the mRNA, as far as I'm concerned, for several days. For me, that's as good as having a vaccine. What I would like to do in 6 months' time is check my antibody levels. And if I am deficient, then I will ask for the vaccine. But at the moment, I think my vaccine should go to somebody else who needs it.
Okay. Well, I think talk to Ashley and David.
Thank you, Jerry. That's very good of you to contribute there. I'm very aware it's 7 o'clock. It's people's evenings that are now their own. So there are one or two other questions, but I think we should finish on time. Sharon, again, thank you so much for joining us. We really appreciate it, and we're very grateful for all the work that you and your colleagues are doing. And thank you for your ongoing contributions to CUH as one of our non-executive directors. It's been an eye-opening hour spent with you. So thank you very much.
Well, thank you. Thank you for coming. Thank you for listening. Thank you for all the questions. And it's an honour and a privilege to do anything to help. And if you see me in the hospital, come and stop me and say hello. I'd really appreciate that. So thanks for listening.
Thank you.
Thanks very much, Sam.
Bye-bye.
Bye-bye. Bye.